Hello, welcome to Singapore Geospatial Week Plus 2020, an event organized by GeoWorks, Singapore Land Authority's Geospatial Industry Centre. So today we are excited to introduce Aditi from AWS and Yong from ST Engineering to share more about AWS and the DroNet platform. So if you have any questions during the webinar, please leave them in the Q&A box and we will answer them at the end of the webinar. So thank you, and without further ado, I will hand over to Aditi. Aditi, thank you.
Hello, everyone. Just a quick check. Am I visible and audible?
Yes, but it's not the full presentation.
Okay, sorry. So, well, looks like, sorry, I think we just tested, however, it's not. Let me share it again. Sorry about this, guys. Okay. So what are you seeing on the screen right now?
Your PPT slides, maybe you can share the full screen at the bottom right hand side, the presenter mode.
Okay. I am not. Okay. Let me do it here then. Is it better?
Maybe then there's a use slideshow. You see if you click, is it full screen?
Is it okay for you now?
Yep,
Okay,
you're able
cool.
to. Thank you.
Cool. Thank you. Sorry about that. And yeah, so I'm Aditi Gupta, and I'm going to, guess I've eaten up some time, so I'm just going to be a little fast, and I'm going to talk to you about the geospatial data on AWS, on telling you why it is important to have data lakes and what we are doing with some of the partners. Our partner STE would be here, who would be talking about their DroNet platform. So let's start, true to our customer, true to our Amazon's, starting from the customer backward. Let's start with some of our customers that we have. NASA, for example. So NASA is basically, NASA's Earth Science Data Systems is the single largest repository on AWS. And just give me a second. It's, sorry. It seems to be, are the slides still showing on your end?
Yes.
Okay, sorry, it's not showing on mine, so I'll just use the other monitor there. So yeah, so basically NASA Earth Science Data System Program is the single largest data repository of Earth data, which is integrating with multivariate and heterogeneous data systems, which is being delivered from the diverse operational platforms. So now, if you're looking at the other links that I have, the Earth on AWS, which is the bottom right link, the Earth on AWS helps you to build planetary scale applications in the cloud with open geospatial data. Now, also when we talk of the open data, I want to also mention quickly about the registry of open data on AWS, which helps you discover the shared data sets that are available on AWS resources. When we're talking of public data sets, I want to say that it's not just the geospatial data that we are working with. A very unique example here is Internal Revenue Services from the United States, which are collecting the NGO data for all the possible financial information which is available about those NGOs and NPOs. So it has been noticed that customers have been using this data, which is open publicly, and driving multiple outcomes from the different kind of data that we have. And that is where I leave you there to see that what is it that you would want to do with the public data sets that are available. Coming back to the geospatial data. Now, if you look at the geospatial data, it basically contains the identifiers that specify the geographic position of an object. Now, examples of this data could include like weather reports, like map directions, or tweets with geographic locations, store locations, and airline routines, or multiple such things. When you're looking at the geospatial data, it's essentially playing an important role in your business analytics, reporting, forecasting, etc. And geospatial identifiers such as latitude, longitude, it essentially helps you to convert any mailing address into geographic coordinates. Now, as it can be seen, this data is growing exponentially and it's coming from different sources. It's, of course, increasingly diverse and used by many applications and people. Now, with this, when you have such a huge data, it brings us to the question on why geospatial data lakes are important and what are some of the asks. So some of the challenges that we are seeing, apart from the ones which we saw on the previous slide, was that the asks are that the data must be organized, it must be well documented, consistently formatted, and error-free. Now, cleaning the data is often the most complex part or most taxing part of data science, and it is usually 80% of the work. And what we call at Amazon, this is called the undifferentiated heavy lifting. And at Amazon, what we are trying to do is, by providing you managed services, we are trying to ensure that this unmanaged or undifferentiated heavy lifting is easier for you. So we bring to you if we were to take it on a higher scale and bring out these components of the data lake which you want and divide it into different segments, you would basically be looking at 4 different components of a data lake, which would be your access and user interface. You will ingest, you will catalog the data, and in some ways also secure, protect and secure. So looking at the architectural, or how, if we divide it into 4 components, how different services will play a part. So let's say today, if you have the database on the on premises or on another cloud or an AWS itself. So if you're talking of the data, you can basically migrate it using something which is called the database migration service. You take advantage of our S3, which is object storage, bringing to you unlimited data storage with 11 nines of durability, along with keeping in lines with the security scaling policies that we have. Then you're able to extract and transform this data using services like Glue, which is our ETL service, extract, transform, and load service. And we are also talking of Lambda. Lambda is our function as a service, whereby you don't have to manage the underlying servers to run certain compute. Next is about loading. So where would you want to load it? Of course, S3 bucket, which is your object storage, could be one of the places. But what do you do with that? Redshift could be one of your data warehouses, which you could be using. Or you could be talking of the EMR cluster, which brings you the capability of Hadoop or processing at scale, adding the virtual servers from the cloud on scale to do all the different types of processing on the data that you have in your data lake. Finally, to explore this data, you could be using Athena, which is our in-place query system where you can have the queries running on your S3 buckets without actually managing the underlying servers there. So it's again a serverless managed service. So overall, if you look at this, the architecture here gives you a data lake on AWS gives you the complete life cycle using some of the services that are available on AWS. Now, coming to the geospatial data and seeing what are the other components of collecting this data. Yes, we spoke about where a data is residing, but that's typically not the case. Your data is typically, it's either store data or it's incoming data. So when we are talking of incoming data, there are different options, and we are increasingly finding that geospatial information systems are finding drones very, very applicable in collecting the data which is available. And these are the advantages that come basically from the facts of them being quick, maneuverable, cost effective, and they're essentially also in good fit for the projects which need a very high degree of rigor in the maneuverability and in the data collection. Not to forget that these are environment friendly and greatly reduce the risk to damage the persons and the property when you're collecting those data. It is also able to go closer to the target where you are looking at, rather than having the airplanes or helicopters or further satellites. Now, with this, it makes them ideal for GIS applications, and some of these applications are listed here in front of you. Now, what is AWS giving to you in this space? On one side, we just saw that data lake, or having an optimized data collection point, as one way of getting your data in one place and getting the inferences out of it, maybe having a single source of truth being one of the components. The other component or true value of all this data comes when you have the actionable and some meaningful insights which are driven out of this data. That's where also your analytics and machine learning comes into play. So I want to take a moment and also introduce you the machine learning stack that we have, giving you that complete solutions in place. So Amazon brings to you the widest and the deepest set of capabilities when we talk about machine learning. The machine learning stack is in itself is divided into 3 layers. So you don't have to go through each of them. I'll just make it simpler for you. So if you're looking at the bottom layer is for the hardcore data scientists who want to manage the underlying infrastructure and who want to manage these frameworks on their own. So that is where we have support for frameworks like TensorFlow or PyTorch and MXNet. And there are other infrastructure services, like you could be talking of the different GPU or the graphic instances, or the FPGA instances. So it brings you a whole lot of spectrum of services there. Next come the machine learning services. So in the machine learning services, this is for the data scientists, which are relatively comfortable with having a managed service there and want to focus on building the model rather than doing the heavy lifting underneath. So it comes SageMaker being one of our popular integrated development environment for your machine learning scientists and developers. So it comes with built-in algorithms and Jupyter notebooks where you're able to run models and you're able to train the models. You're also able to compare the different models to see how the performance is looking like. It also comes with a debugger and an autopilot to train your models in case you don't know enough depth about what is the best algorithm to be implemented or what is the best solution there to be looking for a certain ML problem. So it's good for seasoned machine learning developers, as well as for the developers who do not want to go or do not know too much about machine learning. At the top layer, we have out-of-the-box AI services, which are in the space of vision, speech, text, or chatbots, or you're looking at personalization, forecasting. So once you have the underlying data, you can essentially be making use of this out-of-the-box machine learning and AI services in the top layer and drawing further inferences from this. Since we are talking of drones, since we are talking of geospatial data, I want to also highlight quickly about one of the services that we have for the data labeling. So data labeling is typically one of the most painful points, again, when we are looking at the appropriate images that have been gathered. So how do you ensure that the images are rightly labeled? We have the service which is called the Amazon SageMaker Ground Truth, which helps you in accurately labeling this training data set, which could be partially by machines and with the assistance of humans, makes the heavy lifting much more easier and brings down the cost of data labeling by up to 70%. So with that, giving you a very high level overview of data lakes and machine learning and how they come together, I want to introduce our partner ST Engineering in Aerospace, where they have been using the AWS services in many solutions. And they would be talking about DroNet, which is a network of drones designed for future smart cities to help the end users carry out regular tasks such as surveillance, security, inspection and delivery, etc., to improve the productivity and enhance the safety of the cloud. So with that, I would like to pass on to my colleague, Mr. Yong, so from STE. Mr. Yong, over to you.
Okay, thanks, Aditi.
Okay.
Let me enable my video. Right, can you all see my screen?
Yes, I can. So.
Yes, we can, but I couldn't see you though.
Oh, okay, let me see how to turn on the...
Yep.
Okay.
Yeah, able to see you now.
All right. All right, I will begin. Thank you, Aditi, for the introduction. Hello, everyone, and thank you for attending today's session. My name is Yong, and I'm from ST Engineering Aerospace, working under the Engineering and Development Center, supporting UAV businesses as well as development. In this segment, I'll be giving an introduction on DroNet, which is one of our drone solutions that we have developed in ST Engineering. I'll be covering a little bit on how we make use of geospatial data in DroNet, as well as how we use AWS to manage some of the services provided by DroNet. So what is DroNet? DroNet is a network of systems that we have integrated together to provide a versatile solution for our drone cities initiatives, where drones are utilized to help end users to carry out regular tasks to help them improve their productivity as well as to enhance their safety. So with DroNet, we wanted to provide end user with a complete end-to-end solution where they can streamline their workflow and processes to enable them to focus more on obtaining the results as well as completing their tasks quickly. So DroNet comprises of three key components. The autonomous drone that is designed to comply with safety and regulatory requirements. The drone pods that houses the drone at remote places for automatic deployment and recovery, as well as the drone hub that is an intelligent centralized ground command center. Now, the DroNet is a versatile platform. It can be adopted in many different applications to serve different needs. And this includes surveillance in security or public safety, inspection of infrastructure of assets, mapping and monitoring of an area, or even parcel or food delivery services. I'll play a short video clip here to give an introduction on DroNet and show how DroNet system actually works. So conventional drones requires a dedicated controller to control the drones through a visual line of sight communication. So whereas in DroNet, it is designed for one-to-many operation. Now this is done by connecting multiple drones in a network. This is kind of like an internet of drones out in the cities where the drones are commanded to fly autonomously. So the drone pods allows the drones to house at remote locations where the drones will land at or take off automatically. So to allow continuous operation, the drone is able to replace the drone batteries once it has landed. So with this DroNet workflow, we'll see later how we can apply the DroNet system for different applications. So our drones are designed for autonomous beyond visual line of sight, in short, BVLOS operation. Now this allows our drones to fly at further distance, and it does not require the drone pilot to maintain direct visual contact to the drones to monitor its flight. Now, in order to achieve a BVLOS flight, we need to ensure that the system is reliable. It has the ability to monitor the drone remotely, and we need to incorporate safety features as well as the ability to handle emergency remotely by having features such as hardware redundancy to ensure flight critical components on the drones are constantly available to keep the drone in the air. We also need to ensure that we have safety features and automated failure handling, such as flight path deviation, geofencing, obstacle detection and avoidance system. Now, as you can see, most of these features requires the drone to have a reliable source of localization to allow the drone to know exactly where it is flying and reports its position to the remote pilot at the drone hub. I have prepared a slide here to explain what is BVLOS. As you can see from the diagram, the typical drone operation is usually carried out using a visual line of sight or an extended line of sight where the UAV pilot or the visual observer will need to constantly maintain eye contact with the drones at all times to monitor the drone's flight path. Now this actually limits the distance where the drone can fly. And by default, most of the civil aviation authority will require the drone's operator to operate in this manner. Now with BVLOS, a drone can fly further distance without needing the pilot to keep constant eye contact on the drone at all times. Now this helped to improve the economics as well as feasibility for many commercial applications. Now in February 2019, last year, our company, ST Engineering, is the first company in our country to have obtained the BVLOS permit from our Civil Aviation Authority of Singapore for DroNet to operate in the BVLOS flights. With BVLOS, the pilot and operators can sit comfortably at the drone hub to control, monitor, and manage multiple drones operations. Now, all the information from the drones, such as its location, the health status, the video footages, will all be streamed into this drone hub, where the pilots will be able to monitor the exact location of the drones on the map. But the pilots will rely on the geospatial and video data provided by the drone hub, as well as from the drones to accomplish its mission. So to complete the BVLOS operation, the drones needs to be remotely launched and recovered as and when required. This is where the drone pod comes in. Now, the drone pod allows the drones to be housed at remote locations, placed at a strategic location. The drones can be activated to perform its operation from the drone hub remotely. The drone pod will also be capable of providing simple maintenance on the drones, such as performing pre- and post-flight inspection, as well as replacing and charging its battery internally. For DroNet, we have separately developed a web platform. We call it the DroConnect, to provide a real-time interface to the end user to allow them to have easier access to make requests, to enable them to receive reports, execute video analytics, as well as to distribute the data to different entities. DroConnect actually makes use of AWS to handle some of the DroNet data processing, data distribution, as well as data storage. So these are the list of services that we're using from AWS. Just to highlight a few, we're actually using Kinesis service from AWS to handle the processing of video stream received from the drones in real time. As most of our applications are usually video intensive, this Kinesis service is able to handle our video requirements. We're also using the ECS, which is a highly secure and reliable way to scale up multiple drones operations, each requiring various video analytics algorithms to be executed. So these are some of the video analytics capabilities we are offering in DroNet. Now, this video analytics allows our end user to process the video data and that is received from the DroNet, process them, and extract only the relevant data which is useful to them and which are the data that they are interested in. So right now, as you can see, our video analytics includes object detection of a human, vehicle, weapons, building inspection for building defects detection and identification, as well as 3D reconstruction. So this is a sample of the setup of one of the applications that we have under DroNet. So as you can see, the drone pod and the drones are actually situated near the area of interest. This is where, in this case, it's actually the reservoirs. And the drone hub can be situated anywhere. So with this, the operators from the drone pod can actually activate the drones to operate its reservoir monitoring mission remotely. So once the data is captured by the drone, this data is actually streamed to the DroConnect, where the data are further processed and been streamed to the user. So I have another video here. And it will show the various applications that we offer in DroNet. So the first application is for area mapping and monitoring. I've explained this earlier in my map, in my slides, and it's for reservoir monitoring. So what happened is the drone is actually deployed to scan the reservoirs, to do area mapping, and as well as making use of the video analytics to pick up any flow that is on the reservoirs and assets inspection. We use this for building inspection, and it helps the inspector in terms of their safety. It eliminates the risk for human working at heights. And with the defects that was detected from the video analytics, you can actually cross-reference the defects to the 3D model of the building that was reconstructed. And the third applications that we have done, it's actually security surveillance. So with anomalies that are detected from other ground security systems, the user can actually deploy the drone out to the area of interest and to investigate for any intruders. And with the video analytics, it's able to pick up the humans, and the system will also be able to track the intruders and alert the security officer to apprehend the intruder. So these are the various applications that we have used for DroNet. Of course, I've mentioned before, DroNet is a very versatile system. It can be adopted into many applications depending on the different end user needs. All right, so DroNet, for DroNet, what we currently have is we have a lease, we have a sales system that's going on. We also do provide flight services for this DroNet system. So for more information, I think we can contact Susun from our company, and he'll be able to share with you more. All right, so this is all I have. Thank you.
Yeah, so quickly summarizing the session. So with Amazon and STE together, you could have the end-to-end system right from the edge. We're using drone to collect the data or other mechanisms to collect the data. Your data could also be coming from on-premises. You import it, and ingest, analyze the data, and can drive meaningful insights using this data from using the machine learning platform that we have. So yeah, with that, the platform is open for questions, please.
Thank you.
Thank you. So now we'll proceed to the Q&A. I think we have one.
So I think this is regarding the reservoirs. What is the cycle time to transfer, process the scanned 3D data set from the drones to cloud storage? because the processing will take some time. So usually for cases such as for reservoir mapping, will require a couple of days, like maybe two to 3 days to process the data. So this example, in this case for reservoir mapping, we do not process the data in real time. So what happened is the data is recorded, and then it's streamed to the servers, and then the video analytics will process the data. And at the end, we will tabulate a report, and this report will be sent to the users. So we don't send the entire videos to the users, but rather we generate the reports, and the reports are actually distributed to the user instead. Yeah. So the next question is, can we show our email slides again? Is this the one?
Yeah, I think they would like to have your email. Also,
Right.
we have another question at the chat box. Can DroNet be deployed anywhere in Singapore?
Yes, so DroNet can be deployed in Singapore, but what happened is, because we still need to seek the Civil Aviation Authority of Singapore's approval. So we need to apply for permits and get their approvals to operate the system on areas, on specific areas that the end user may be interested in. Yeah. Okay, I think I have another question. It says, I'm interested in using DroNet in a business application. How would this happen? Can we engage ST Engineering with developing the applications, or what's the business model of ST Engineering with this? So DroNet, like I mentioned before, it's available for lease for the hardware and as a sales of the hardware. We also do provide flight services for some of our clients to operate the system for them. And at the end, we will deliver the results or the reports to them through the DroConnect platform. Right. So if you require certain customization, because the drone systems or the DroNet system is developed in-house, we do have an engineering team that is able to do customization, to customize the drone to carry different payloads for different applications. So I think we can discuss, and you can actually email us, and we can further discuss. Must DroNet always have a man in the middle? So must DroNet always have a man in the middle for carrying out any mission? Typically, the DroNet, it's a multi-drone platform. It is actually operated by a very lean crew in the drone hub. So usually you have a man to monitor the drone operations, but the drone is completely autonomous, which means you can just send out the flight path, the flight plan, and the drones will be able to carry out the mission by itself. So the man is purely just there to monitor and handle any emergency that may arise. For specialized use case, can we use the DroConnect platform to train the AI models to detect animals or cars? Yes. So our video analytics algorithms are actually based on deep learning algorithms. So you can actually use the DroConnect platform to train the analytics capabilities to detect different objects. Yeah.
To add to this, the Amazon AI services like Amazon Recognition Video comes with the pre-trained model where you can have this, identification already done without training your model. You just need to feed the video and get the labels there.
Right. Thanks.
Okay, thank you so much for today. Thank you, Aditi and Yong, for sharing.
Thank you.
Thank you.
All right.
Thank you all for tuning in to the webinar. Before you leave, please check out our other webinars by scanning the QR code. So thank you, and we look forward to see you again.
Thank you.